Going on, guys? Today we're going to learn about the last concept before we move on to integrated math 1 stuff. And the very last concept is going to be still talking about solving for a single variable, but we're going to be talking about two special cases today. So the first case we're going to be talking about is where there is literally no possible solution. Okay, so where there's no possible solution. So that equation, an example of that equation, looks like this. Okay, this is an example of where we're going to get no possible solution and what that looks like. So here we go. We're going to solve this like we normally would using the same steps that we normally would, where we're going to get x by itself, or at least attempt to. All right, so you can see we have x's on both sides, but let's just go ahead and follow the steps. Let's get rid of all parentheses first. So we're going to call this 15x. And then 3 times positive 2 is positive 6. And then that equals 15x. Now, we need to get all the x's on one side. So at this point, I think it's pretty clear that we need to subtract 15x from both sides because we want to be able to move the 15x. I'm thinking on the left side over to the right since we already have the 6 on the left. So we're going to go ahead and do that. Subtract all 15x's to get rid of all of them. Whatever we do, we have to do to both sides. And so look what happens. 15x minus 15x. 15x minus 15x. Now be careful because on the left side, you're left with 6. But on the right side, it's not just blank. You have to put something, and it's the placeholder, which is 0. Now, here's where the issue lies. You cannot have no x's. They just disappeared, right? And does 6 equal 0? No, 6 does not equal 0. So since this statement is false, and since the x's went away, variables canceled. Okay, we're going to, ooh, that's not a good. Variables canceled. Hopefully that's how you spell it. Then we know that we have no solution. So the answer to this is, once we get this, that's not our answer. Our answer is actually no solution. Okay, we don't have a solution. Now, what the heck does that mean? Like, how do you not get a solution? So I pulled up Desmos. Let me pull it up for you guys. One sec. Here it is, and you guys can clearly see that I'm going to put the exact same two equations that we just did. So since you're taking notes, you already have them written down. But one of them is up here. You can see me clicking it. Hopefully you can see my mouse moving and I'm clicking this. So that's what the first equation looks like. The second side of the equal sign said 15x. So if we graph these separately as two separate equations, what happens? How come we have no solution? Because the graphs never cross each other. So the solution is really where the two lines cross each other. And we'll learn probably more about that later on in the school year. But for now, this is what it actually means. If you have no solution, that means that the two graphs that they make literally never cross each other. All right, cool. So now the other option that's special besides no solutions is going to be the one where you have an infinite number of solutions. Remember, infinite means means it goes on and on and on forever. So you have just an infinity number of solutions. So let's do an example of what that's going to look like. Okay, and I like to just use x's all the time. And remember, we're going to plug this into the graph. I'm going to show you in Desmos pretty soon. What that means. How the heck could you have an infinite number of solutions? Let's see what that looks like. All right, let's pull out the purple. All right, let's go ahead and follow the steps like we always would. So negative 2 times a positive 4x is a negative 8x. And negative 2 times positive 1 is negative 2. Look at that. That's pretty cool, huh? So now we're going to go ahead and we're going to solve this all the way down just so you can see what's up. But right now you can already see that the equation simplified to be the exact same thing. And so we're going to take it all the way down so you can see, get a better picture. So let's go ahead and use reverse PEMDAS. It doesn't matter what side you want to put the x on. I'm going to say that I'm going to try and make the x on the left and the numbers on the right. So because of that, I'm thinking that I want to move this -2 and get it out of here. So how do I do that? Have to add 2 to both sides. So I'm just trying to use a strategy like I would normally use in any problem, is figure out what direction I want to go and then get rid of everything on the side you don't want it on. So this cancels, but wait, this does too, because it's the same number. So now what are we left with? -8x equals -8x. Now, we have to use reverse PEMDAS, no more addition and subtraction. So what do we have to do? Divide, because we're multiplying, and the opposite of multiplying is dividing. So you divide by whatever you were multiplying by. And this looks like this. All right, so now you have x equals x. Well, that's weird. So even if you were trying to get them on the same side, you'd end up with 2x's. Well, I mean, how do you get rid of, how do you take with the x and move it from one side to the other? We'd have to subtract it. So if we did, what are you going to do? Say subtract x from both sides, and now you get 0 equals 0. So if you end up with all the x's gone, and a number just equaling a number like this, you know that you have what? An infinite number of solutions. Infinite number of solutions. This means that any number that you plug in for x will make the equation true. And you could try that out on your own if you want. Pick any number and plug it in for x, and it's going to make the equation true. Okay, the way that the book did it was a little bit different. Once it got to this step right here, equals -8x minus 2, this step that you're seeing right here, they just said, hey, they're going to subtract 8x from both sides, or add, sorry. So they went ahead and did this and immediately tried to move x's, which is fine. And they canceled those out, and they end up getting -2 equals -2, which is the exact same problems because all the x's, the variable goes away, right? Goes away. So just like the last one where the variable went away, okay, this time you end up getting the same number equaling the same number. Okay, so if you get the same number equaling the same number, that is true all the time. That's why you have an unlimited amount of solutions. All right, let's show you on